Hey guys, welcome to another video of statistics, and the objective of this video is to go through a 5-number summary of a specific set of data, and afterwards we're going to represent these 5 numbers with something called a box plot. So let's start off with a 5-number summary. So normally we're being given a set of data and also a sample size called n. Okay, so a sample size is basically the amount of values that are given in your data. So if we go back to our previous example of the amount of people in class 1D, so we said that there were 10 males in class 1D, okay, and we assigned that to x1, and that there were 6 females in class 1D, and we assigned this value to x2. So we have 2 values, 10 and 6, and because we're given only 2 values, we conclude that our sample size is just 2. So therefore, n is equal to 2. And that is our sample size. And so we summarize data, and especially with sets that have much more larger sizes, with something called a 5-number summary. So these are the 5 numbers, okay? And so the first number here, x1, that's the minimum. q1 is the lower quartile. x squiggle is the median. q3 is the upper quartile, and xn is the maximum. So this is the maximum number in the set. So xn, the n here, is basically the sample size, okay? So remember, the sample size is basically the amount of values that are given to you in your data set. Okay, so firstly, let's go through one of the 5-number summaries, okay? So let's start off with the minimum. So the minimum is basically the lowest number in the data. So for example, let's say we're given a data set of 4, 2, 1, and 3. So firstly, what we do here is that we rearrange it from the lowest number to the highest number. So 1, 2, 3, and 4. And so obviously here, the minimum is obviously 1. So we can conclude that x1, our minimum in this data set, is 1. Okay, so the next number we'll go through is the median. Okay, so the median, x squiggle, and some other people, they call this value q2, is basically a value such that at least half of the data are less than or equal to x squiggle, our median, and at least half of the data are greater or equal to x squiggle. Okay, so one way to really understand this is to look at an example. So let's say we had a sample set again of 1, 2, 3, 4, and 5. Okay, a different sample set. So our sample size here is 5 because we're given only 5 numbers. So if you write them all out, right, the median is basically the middle number in our sample set. Okay, so the middle number here is 3, x squiggle. And so the way that I think of median is that the amount of number on the left-hand side of the median should be equal to the amount of numbers that you have on the right-hand side of the median. Okay, so for example, if your median here was 3, the left-hand side of 3 should only have 2 numbers. Okay, so there should be 2 numbers here. All right, and so on the right-hand side of 3, right, there's also 2 numbers. And so because the amount of numbers on both sides of 3 are exactly the same, 2, which is 2, there are 2 numbers. Okay, that means that 3 is our median, the x squiggle, just because there are exactly the same number of numbers on both sides of our median, 3. So therefore we conclude that x squiggle is equal to 3. So let's go to a special case where, let's say for example, your sample size was a multiple of 2. Okay. So let's say we have a new sample set here, 1, 2, 3, 4. Okay. So our sample size is 4 because we have 4 numbers here, which is a multiple of 2. So again, we write them out, 1, 2, 3, 4. Okay. So the median here isn't 2 or 3 because, for example, let's say you use 2. Okay, so the left-hand side of 2 is only 1 number, okay? And the right-hand side of 2, there's only 2 numbers. And so you can just see that the amount of numbers on both sides of 2, right, aren't the same. And same thing with the number 3. So therefore, 2 and 3 cannot be our median. So what we do here is that for sample sets that have a multiple of 2 as their sample size, right, we will take the middle 2 numbers, okay? So in this sample set, 2 and 3 are the middle 2 numbers, and we take an average of 2 and 3, which in our case is going to be 2.5. And so we can conclude that the median of this set is 2.5. Okay? So let's jump to the lower quartile. So the lower quartile is defined as the median of the lower half of the data. Okay, Q1. That's lower quartile. So if you look at our example again of 1, 2, 3, 4, 5, sample size being 5 because there are 5 numbers. Okay, our lower half with identify, which is 1, 2, and 3. Okay, which includes our median. Okay, and so afterwards we then take a median of this lower half set, which is 2. Okay, because 2 is a middle number. And so we can conclude that Q1 of this set is just 2. Again, we're looking at our special case. If we had 1, 2, 3, 4 as our sample set, and that our sample size is 4. So firstly, we identify the lower half, 1, 2. Okay, so the reason why 2.5, our median, shouldn't be included in our lower half set is because the median wasn't in our original big set at the beginning. Okay, it wasn't the value that we received in the big set that we had at the beginning. Okay, so therefore our lower half, okay, is 1, 2. Okay, so therefore we take a median of 1, 2, which is 1.5, and we can conclude that the lower quartile is 1.5. Okay, Q1. Okay, so let's go through the next number, which is the upper quartile, okay, which is Q3. So the upper quartile, which is defined as the median of the upper half of data. Okay, so again, with our example 1, 2, 3, 4, 5, with a sample size of 5, and so we identify the upper half, which we will find it's 3, 4, and 5. Again, this should include the median because our median 3, right, is in our set. So the upper half's median is equal to 4. Okay. So now our upper quartile we can conclude is 4. So now let's look at our example with a special case. Okay, so 1, 2, 3, 4 as our sample set, and is equal to 4, the multiple of 2. Okay, so now our upper half we identify as 3, 4. So again, our median 2.5 shouldn't be included in this set because 2.5 isn't in this set here. Okay, so it shouldn't be in our upper half set. So therefore, our upper half, which is the two numbers here, right, should be just 3 and 4. So the median of the upper half is equal to 3.5. Okay, and we can conclude that Q3 of this set here is 3.5. So next number we're going to go through is called the maximum, xn, and that's defined as the highest number in the data. So again, if we went through our data set of 1, 2, 3, 4, 5, sample size being 5, the maximum number should be just be 5 because this is the highest number in the set. Okay, so if we went through the example of 1, 2, 3, 4, 5 again as our sample set, and the sample size being 5, okay, we can give a 5 number summary like this, okay, as calculated before. So minimum is equal to 1, lower quartile is equal to 2, median is equal to 3, upper quartile is equal to 4, maximum is 5. And so we again have to find specific values, right, using these 5 numbers. So one value that we define is the range. So the range is defined as xn, which is the maximum number, minus x1. So using our example here that we have of 1, 2, 3, 4, 5, our range is just equal to x5 because we have 5 as our sample size, minus x1, which is the minimum, and that's equal to 5 minus 1, which is equal to 4. And the other number that we define is called the interquartile range, which is basically Q3 minus Q1. So IQR, which is the interquartile range, is just Q3 minus Q1, which is equal to 4 minus 2, which is equal to 2. Okay, so we can conclude that the interquartile range is equal to 2. Okay, alright guys, I'll see you in the next video.